Good day to you. This is Anagalactic bringing you a summary of science. We are going to attempt to go right from the beginning to the present day and explain everything about quantum mechanics. Now, I've been studying this for upwards of 2 years, and I've attempted to produce this sequence several times, but as you might imagine, since it's the most difficult problem ever faced by science, it's not easy to summarize. But that is my job, my chosen occupation, so I'm going to now introduce to you trans-Euclidean geometry. I think you can see that. I have some diagrams prepared. You can go back 2 videos and see those diagrams, but I'm now just going to run through it. Beginning with the Euclidean point, I discovered that there is a second axiomatization where instead of getting a 1-component Euclidean point, you can get a 2-component structured point. And that replaces the Euclidean point. Now what that implies is a complete change to the mathematical system. And that's the discovery that I made 3 years ago, is a 2-component number system. Now there's a lot of footnote information because of several apparent paradoxes in doing that, which prevented all of our mathematicians from seeing this. The trans-Euclidean point is reached by the Euclidean point, so we do start with Euclid. It is significant enough to mention that there are 2 points, but they're the same point. That's a contradiction, but it's not. It's superpositional. They're both true, but they're true in 2 different systems that are hierarchical. The system we use is the 1-component line system, where numbers are 1-component numbers. Now you've heard of complex numbers, which are 2-component numbers. That's extremely significant because it's the first time a 2-component number system was ever tried. It was so successful that it replaced every other number system, and now science only uses complex numbers. Only uses complex numbers. The real numbers are part of the complex number system. And it could be said that all number systems can be extrapolated from the complex numbers. But that's not quite true either. I only mention that so that you know that there is such a thing as a 2-component number system. The y-axis is treated differently, it's metricized differently, which introduces a circular function using the calculus and using Euler's E number. So that's a thumbnail sketch of the 2-component number system that has been developed. It is incorrect, and it can only be incorrect because it still uses the horizontal axis with the single component numbers. By having a different metric based on the square root of -1, you literally complexify mathematics. That's considered to be a boon by your scientists, I'll just state clearly, just showing just how psychotic they are. The calculus combined with complexity takes about 12 to 16 years to master to some threshold of usage. It cannot be understood. The calculus system is a sign of disease, and the complex numbers seals the grave. So we need to get out of that because the universe doesn't use the 1-component number system that basically is our inheritance from Euclid. So we must go back to Euclid and discover his mistake. He made a huge mistake, which it took 2,500 years to discover. I discovered it. So that's what you're going to get. There are 2 points. Now I want you to see this. The one on top says Euclid, and it's 1 component. Below you see there's the trans-Euclidean point, which has a little dot in the middle. Right? That's a 2-component point. Now that's what we're going to study today so that you finally understand it. So I hope you are ready for some intensive thinking. Here we go. To assert that these 2 points are the same requires some elaboration, because one of the points has an interior, but the Euclidean point has no interior. Therefore, it can have no exterior. We call that null. In English, it's nil. But it's absence. It's non-existence. So Euclid, it begins psychotically. To assert that these are the same point requires some elaboration. That's called superposition. Superposition. And superposition is hierarchical. Okay, it's hierarchical. And this has to do with the calculus relationship of the integral, which is big, with the infinitesimal, which is small. What does the integral and the infinitesimal have in common? What do they have in common? Infinity, infinity, and imaginarity. Now, you're probably starting to guess that this is so profound and so synthetic. This is not only going to change science. It's not just going to change physics and mathematics. It's going to require you to change your mind, to actually restructure your own mind. And that will entail some risk. But it's common in science. Whenever we go out in the cloud to form a hypothesis to try to push the envelope, you're risking your sanity in a small degree. It's very unlikely you'll go completely bonkers. But in this case, you could actually split your mind and not come back. You will. Nobody's ever lost their mind this way, but you will have to lose your mind. It's very similar to taking a psychedelic, except this is pure rationality. Well, just because it's rational doesn't mean it's safe. When you get a direct glimpse into reality, and you understand how your consciousness is engaging reality, and you get it for the first time, you might not come back. You'd just be a basket case. It hasn't happened yet, but that's only because so few people have gotten close enough to try. I'm going to bring you right to the edge and kick you off the edge. But you might resist. Don't. When it comes time for me to kick your ass off the edge of the abyss, just recognize that you'll develop the ability to levitate and come back. So we can show that these 2 points are parameterizable. That is, really inversely. When Euclid began elements, he began with 2 sentences. And the second sentence was the axiomatization of the line, what we now call 1D. But in order to establish the line on the axiomatic basis that Euclid desired, he had to begin with a point. And this is both his genius and the curse of Euclid, that point does not exist. He defined non-existence. And we've been saddled with it ever since as linear 0, which destroys the linear number system. And I'll show you why that's both true and not true, because it's superpositional. This is the Schrodinger's cat problem, reintroduced at the beginning of human time. Euclid defined the line as points. That is called quantization. So the quantum paradox begins with Euclid. We can define both the Euclidean point and the 2-component point that I discovered on an inversion. In other words, they're 2 forms of the same thing. And already that might be so baffling to you that you're afraid or you're angry. That's normal. You're going to have to ride that wave. You're going to have to trust me, or you're not going to get it. So let's go on. A full proof of mathematic inversion must wait. It must await our two definitions of each point. I need to explain to you why I can't just show you the invertibility of the Euclidean point with the trans-Euclidean point. They're geometrically related. Because it turns out you cannot get rid of the Euclidean null point. But it's a derivative number in the linear number system. 0 is ultimately peculiar. It's really not related to the numbers. It's an artificial number. But it can be proved to exist. And then it can be proved not to exist. And that is the basis of the quantum paradox. That the point that Euclid defined is one of 2 points, both of which exist in a conjugal relationship that's hierarchical. In other words, it's non-commutative. You can derive one of the points from the other, but it's not the same if you do it this way to get this point from the Euclidean point, or you get the Euclidean point from the point I discovered. You can do that in 2 ways. You can derive one from the other. Well, you might ask, what in the world are you talking about? Deriving one point from another when they're superposed. You can't see that until you turn your attention to the plane. And the plane is undefined. Although it's defined in Euclidean space, it is defined incorrectly. And René Descartes, a monumental jackass, decided to formalize what ends up being 2D. Well, 2D is the beginning of psychosis because you're squaring it. You're squaring the space. You're squaring the plane. Nobody has ever realized how insane that is. The plane is not naturally squarable, but you see it is if you begin the way Euclid did with the linear center point, which is 0. It's right in the middle of the negative and positive numbers. Well, that makes it an infinity. Technically, it's inverse infinity. That has a name. It's called the infinitesimal. I'm going to show you that you cannot reach that. That the null infinitesimal is a contradiction. That if you have an infinitesimal, you have a quantity. That's the nature of an irrational number. That it always has more. The reason it always has more digits is because it's substantial, but you can't define it numerically. That's because of Euclid, and that's the quantum paradox again. We know one of these points from Euclid. It's called the 0 linear dimension. The 0 linear dimension. Those are the exact words that Euclid said in the first sentence of the book that overtook the Bible and stomped the Bible out. Euclid is the most popular book, called Elements. And it begins with a lie. The 0 linear dimension. That's a contradiction of reality. The universe does not know what that means. Well, that's how your scientists have developed every form of science in physics. So this is called the point axiom. It's the first sentence in Elements. It's like in the beginning, God created the heavens and the earth. Well, that's substantial, but Euclid said, I can do God one better. The beginning of psychosis. The point axiom is that the basis of all mathematics, the basis of all geometry, the basis of all that we call rational logic is non-existence. That leads to the quantum paradox. That's what you're going to find out. We may now proceed to our definition of the second point axiom. I deserve about 20 Nobel Prizes for this discovery. So get on it. Make sure that I become famous. I'll be dead by then, so this is pure altruism. I'm just giving you this for free. I know that you won't accept it. That's why I'm doing it, is to hurt you, to make you sad. We may now proceed to the second point axiom that I discovered. To do so efficiently, that is optimally, we simply complete the Euclidean axiomatization so that you'll see that the madness begins right away. Euclid, don't forget, lived in the Bronze Age, right after the dinosaurs. Extremely ignorant, stupid Greek. He's not like Einstein. I'll show you that he is. The way Euclid, that is, that Einstein is just as stupid as Euclid, because you can't get away from Euclid. I did. That's what you're going to find out. So in sentence 2 of Elements, Euclid does what he wants. He began with a point because without the point, he could not define his idea of a line. And now I want you to see another diagram. This one. This is just to kickstart your visual. Look at C with a circle around it, and then S with a square around it. These are the two possibilities for parameterizing the plane. Now, every mathematician on Earth will tell you that the plane can be parameterized with two orthogonal lines. Do you know what that does to the center point? It restructures it. So now it's not only non-existent, it has a structured non-existence because it's the center of both lines. That's considered to be so magical that it has replaced the religious sentiment, the religious faculty of every modern mathematician. And that's why you're not going to find any mathematicians who believe in a deity. They already found their deity. So it goes pretty deep. So the second point axiom. The key to this axiom is related to numeric componency. Now, your brain has got to be pounding right now because you're so dumbed down. You can't even understand a simple logical statement. So let me run that by you again. And try to think this time. I am dead serious. You're going to have to force yourself to think. Or you're just going to turn this off and be dumb. You're going to blame me for being too complex. That's not what's happening. It's because you're too stupid to understand a rational argument. So listen carefully, because this is going to answer the questions in physics. The key to the second point axiom is related to numeric componency. That means the number of numbers in the number. And if you don't understand that, get lost. Okay? A complex number has two component numbers. It's just sad that we have this word number that's being used in three different ways. You're going to find out the same is true of the point, as there are more than one definition, and there's more than one definition of a line. Because we haven't come very far since the Greeks, we haven't developed a robust logical language. So you're going to have to catch up with this right now. No more delay. Numeric componency is no new concept. You can have a one-component number. All right, here's your quiz question. Give me an example of a one-component number system. A one-component number system. Is that redundant? No. There's such a thing as a two-component number system. They're called the complex numbers. So there is such a thing as a two-component number. Well, what are the two components? They're numbers. I'm sorry, but we're stuck with that. So just remember, a component number is not the same thing as a number. All right? But it's hierarchical. That's superpositional, as you'll see. Numbers may be said to derive from geometry, yet their relation is closer to duality than to strict derivation. One could even assert an identity between what and what. Well, for instance, an identity between Euclid's point and the number 0. Correct? Yes. So they are identical. What about the line? You know what the line is in terms of numbers? It's the numbers. That is the line. It's all the numbers. But if you say it that way, you're going to confuse yourself and you'll miss everything. So let me straighten the situation out for you with the addition of one simple qualifying word. The line consists of single component linear numbers. And that is a bit redundant. A single component number is on the line. And the line is made of all the single component numbers. That's an identity. Have you ever heard anyone say that? You might have, but it wasn't emphasized in the correct fashion as I'm doing now. A hierarchy does exist, a form of non-commutativity. Now, if you've forgotten what that is, let me remind you. When you have 2 times 3, you could switch it around and say 3 times 2. Are those identical? According to the non-commutativity, according to the commutativity rule, 2 times 3 and 3 times 2 obey the commutativity principle. That is, you can reverse the numbers and it's the same. Isn't that what we were taught in school? Multiplication is commutative. Now let's make sure we understand that. I know now it's so simple you're sad. Well, you're going to have to get used to the ultimate simple things, which may bore you, and the ultimately complex things, which confuse you. So, unless you can find a way through that, I'm trying to help you, but pay attention because this is absolutely critical. What is commutativity? Or commutativity is really, you should say it right. It's easy to shorten that. Commutativity is, I've heard several mathematicians make that mistake, and I do too. I just did. It's commutativity. Commutative. That means that the two terms are interchangeable in the operation. There are 2 forms of commutativity, and the easiest one is on the line. The commutativity of addition. If you add 1 and 2, it doesn't make any difference which order they're in because the operator controls what happens, and it doesn't make any difference which comes first in the terms. We all know that. So that's the commutativity of the addition operator. Is subtraction commutative? No. The first number will be the number from which the second number is subtracted. So that's not commutative. 8 minus 2 is not the same value as 2 minus 8. So now when you go to multiplication, you're going to be tricked. And all the mathematicians tricked themselves, and they tricked you and me. and I finally understood their fucking lie. Here's what we were taught in school, that multiplication is commutative in exactly the same way that addition is commutative. Is that true? Well, you see that it's not quite true for addition because the inverse is subtraction and they're not commutative. So even that's a lie. Addition is not commutative. If you're considering the paired operators as one undoing the other, when you add 1 to 2, you get 3. When you subtract 2 from 3, you get 1. So it does seem to be commutative, but I think you are starting to see you have to be fucking careful about that. It's only commutative for one of the paired operators. It's not commutative for subtraction. The order, called the hierarchy here, it's a lesser form of hierarchy, is order. Hierarchy is based on order, so my statements are true. This is pure logic, so it may, be causing you a rash on your fanny. You better listen up, because I'm the only man who knows this stuff, and I'm the only man who can explain it cogently. All right. What about multiplication? Is that commutative? Every mathematician who has ever lived teaches that that operation is commutative. Is it? Is 3 times 2 the same as 2 times 3? If you look at the numeric result, you would say yes. And that's why mathematicians say yes. But isn't there a geometry involved? You know there is. What about the geometric representation? Draw your Cartesian grid on the plane, already a mistake. And now you have the x-axis, which has your 2, and the y-axis, which has your 3. Oops! Now you see the lie. No, they're not commutative. Multiplication is non-commutative. It's ordered. If the 2 comes first, then by convention, it's on one of the 2 axes. You can't exchange those axes. You have to define it exactly. You know why? Because of the shape that emerges. If you go 2 on the x-axis and then 3 on the y-axis, you make a tall rectangle, correct? But what if it's 3 on the x-axis and 2 on the y-axis? Those 2 shapes are not the same. One is lying flat and the other one is standing up, and they are not the same. You can see that they're not the same. So 2 times 3 is not equal to 3 times 2 in geometry. Well, that's what your goddamned mathematicians forgot about. For 2,000 years, I'm simply bringing it back up. Now, I mentioned that to make a very important, and I don't want to say point, because then you'll start rolling up spitballs and throwing. It's like when Groucho Marx said in front of the class, which also had Harpo and Chico in it, he said the phagocyte, they rolled up spitball because he said fag. Well, it's the same thing. Let's get to the point. Okay. I like to have fun. All right. Numbers may be said to derive from geometry, yet their relation is closer to duality than to strict derivation. One could even assert an identity. Well, I just showed you. Yes, they are identical, aren't they? You can pretend that they're not if you like pure mathematics. Well, if you like pure mathematics, you're an idiot. A hierarchy does exist, a form of non-commutativity. What this means is that the notion of componency is oriented. Now, in an operation, a mathematical operation, either addition or multiplication, those are the two operators, are plus and times. Those are the only two operators, obviously. They each have an inverse in their system, though. So your stupid mathematicians never fail to mention that. But they're stupid. There are only two operators, but each operator is a pair. So all you have to do is name the primary. Well, which one is primary? Addition or subtraction? It's addition. Strictly speaking, there's no such thing as subtraction. So for the line, there's only one operator, add, and there's no such thing as subtraction. That's a false operation, and I'll prove that to you later. You don't need subtraction. That's a shorthand for adding a negative number. If you use negative numbers, you never need subtraction. If you don't know that, it's because your education is severely deficient. So I'm just telling you the truth. Now when you get to multiplication, everything changes. Everything changes. No relation to addition at all. You and I were taught that multiplication is repeated addition. That is untrue. That's absolutely wrong. There's no truth in that statement. Multiplication is unrelated to addition. I'll prove that to you. We're getting there. What this means is that the notion of componency is oriented because one componency does not logically imply the existence of two componency space. That's why we have to start at the plane. Because the plane, even in the Euclidean construction of squared space, is two componency space. René Descartes, the retard, said that that has to be x and y. That's for analytical. It's called analytical geometry, but it's actually not geometry at all. Although we say it is because we don't know what geometry is. And our physics department proves that now. They never understood their own number system because they never understood Euclidean geometry. And now it's biting them in the ass. And you and I are paying for it. I will get us out of that trap. Here, the word space is being used in its established geometric sense. Whereas space is simply a mental construct, though the line that Euclid invented is now known to be a space, but it's a peculiar space, isn't it? It has no content. All it is an imagination of the poisoned human mind, that there's even such a thing as a straight line. I'll prove to you, no there's not. There is no such thing as the Euclidean line. But it's superpositional, and that just, you could say it ruins everything and it'll drive you insane and you'll hate me. But if you're willing to go along for this ride, you're going to find a miracle. So pay attention. This took a lot of work. And it's not just my work. It's all the mathematicians and scientists that came before me. Space is being used in its geometric, you could say, abstract sense. It's not space, such as physical space. We're getting to that. But to get to physical space, you first have to have some kind of space. No matter how you construct it, there has to be some kind of space. Well, if you begin with a line, you'll never find it, because that's not spatial. It's stupid. It's a space that has no space. That's called an extrinsic geometry. In Legoland, we call it a grid. Well, already that's psychotic. You're going to make a grid to explain reality. Well, you're going to end up retarded. I'm just telling you. Pay attention now, because this is the transition. We now are looking at the plane, And I want to show you this again so you can remember. This will trigger your geometric faculty. This. This. Look at that again. Do you know what that is? That's the plane. But the plane is being parameterized in two ways. The one on the left that says visualizable has never been tried. Never been tried. Is it any wonder I use the word retard so much? That is the parameterization of the plane by a circle. And then you have Euclid, the squared plane. Have you ever wondered at the term c squared, the speed of light squared? Does that even make sense at all? To square? Square. It's a square. Is that a little strange? Yes, it leads to the quantum paradox. So the circle labeled C is defining planar space, and the square S is defining planar space. They're both defining planar space. That is called superposition. That you have a squared plane for your linear numbers. What I discovered is the parameterization of the plane in two-componency space that's non-additive. It's the multiplicative plane. So that's why I introduced the commutativity of addition and the commutativity of multiplication. They're quite different. They parameterize the plane in two entirely different ways. One is with squared space, so that everything is linear. And the other one is circular space, where everything is curved. That is so profound, but let's go on. So now we turn to the plane to parameterize it. You know what it means to parameterize an object in geometry? It means to give it numbers. Now, if you start with a Cartesian mistake, then you're going to end up with squares. And then when you switch to 3D by adding the third orthogonal line, then you have cubes. Well, Einstein inherited that. Can you imagine Einstein, one of the most brilliant minds, I would have to say, that humanity has ever produced, was trying to visualize the dynamic structure of the universe. And he was fascinated with gravity, and he was fascinated with the synchronization of clocks. So was Poincaré in France. There's a whole book on this called Einstein's Clocks and Poincaré's Something Else's. And it's a good book to read because it shows you that Poincaré and Einstein were locomotive fanatics. They loved trains. Well, they didn't. They couldn't have cared less about the trains. But they were dealing with the most important problem in Europe at the time, which was also coming to America as well, as the locomotive, the steam locomotive, was giving the ability to nations to link their cities together and internationally. So the railroads were being built out as fast as humanly possible in both Europe and England at the turn of the century. And in order to make that work reasonably for the humans who would use the locomotives, you had to synchronize the clocks between Berlin and Paris. And that cannot be done. It's impossible to synchronize two clocks, because the further apart they are, the more wrong they are. And so you have to do something about that, and nobody could figure out how to fix that problem. So Einstein and Poincaré were trying to solve the problem of synchronizing locomotives. That is, synchronizing the clocks in the source and destination cities. And they found out that that cannot be done. The universe forbids it. So both of them developed relativity. And that was the beginning of relativity. It had to do with trains. We shall now explore the relation between squared plane and circular plane. Each space, those are two different spaces, each space has a unique two-component parameterization. They're different. The squared plane is based on add. The circularized plane is based on multiply. I discovered that. Nobody has ever seen that. Here is a diagram which may help you. You'll see there's a line and then there's a circle. The line has a center and the circle has a center, but the line has a square center. The circle has an undefined center. That is not Euclidean zero for the circle. And I'll prove that to you now. The greatest insight in the history of geometry. I got it. No one else did. This is my discovery. Don't. Okay. Consult the prior video called Apologia, where I let you know the stress that I'm under right now. So we have, for the squared plane, a function that relates x to y. But for the circularized plane, oh boy, what are we gonna do? You are now visualizing a redefinition of the point. And this is what's going to split your mind. You will not be able to handle this. And to the degree that you find yourself unable to handle the truth, that's the beginning of an entirely new universe for you and for science and for humanity. And I discovered it. The function that parameterizes the plane. Do you know what the function is that parameterizes the 2D Euclidean plane that the retard Descartes made famous? The Cartesian plane of x and y? What is the function that defines distance? Do you know? It's called the right angle law. Oh, I'm sorry, I'm so stupid to have made that silly mistake. It's not the right angle law. You've never even heard of that. What is it really? Oh, it's the Pythagorean theorem. The Pythagorean theorem. The Pythagorean theorem? What the fuck does that mean? It means the right angle law. Okay, you're starting to get some intelligence back. Keep going. Go with me. Take a dare. Try to think for a change. The E point, okay, the Euclidean point, is null. We can now prove that the line is mathematically embedded in circular space. This is called the antipodal theorem. And the way you can visualize that is by drawing a line. Do it this way, just draw it plus and minus so it's balanced all the way on 0. Let's get over here. Plus, minus, everything's balanced. 1 and negative 1 add to 0. 10 and negative 10 add to 0. Infinity and infinity add to 0. So now you have two infinities that add to 0. Well, that means that 0 is an infinity. So you have the infinitesimal, which is null. That's the mistake. And now you have two infinities that have no identity except on nullity. So you have nothing, and your line is nothingness. It has two nothing infinities that balance on nothingness. So there's nothing there. Nothing is there. That's your line. Now you take two of them. Well, you're heading into psychosis. You're making squared space. That's why you have the value c squared, which makes no sense. None. So how in the world are we going to get out of this scaffolding, this Lego trap, where everything is nothing, and now you have squared nothings, and everything has sharp corners? My God! Well, take a look again. What if you begin with a circle? Well, you're going to have to redefine the point. Remember how Euclid began? He began with a point because that's the only way he could develop the axiomatization of the line, which creates linear space, which after hypercubic space that Albert Einstein invented, now you have space-time in hypercubes. It's no wonder it doesn't work. And it doesn't work. We can fly through outer space all we want because of Einstein's relativity. That's why it's worshipped. So it is a valid linear solution, but it's linear. So you're stuck with nullity. Well, then you're going to get a supermassive black hole. And you're going to get the Big Bang. And you're going to get the quantum paradox. And you're going to make no progress. And humanity will not get the solutions that humanity deserves to get. Because Euclid was retarded. And Einstein was retarded. And your modern mathematicians are collectively retarded. Stupid people. They're dangerous, too. And they're evil now. So it goes deep, this shit. We can now prove that the line is embedded in a circle. And here's how we do it. And for the rest, you're going to have to consult my previous 5 lectures. And if you don't, you'll remain an ignoramus. And worse. And you'll be taken right down to hell. I'm the only hope for you now, if you're a rational man. So thank you for tuning in. Pardon my ellipticity, but I'm at a crisis point now. I'm about to go to live stream. Stay tuned. We'll be right back.